Hey everyone, my name is Saurav Sarma, an assistant professor in the Department of Statistics, Cotton University, and this is our first lecture in a series of lectures where we will discuss various aspects of statistics that can be used in biology. That means, in short, we will discuss biostatistics, right? So today in this lecture we will define some preliminary knowledges or preliminary terms that are commonly used in statistics, or some basic concepts that are very vital to understand the further theories of statistics that we will discuss in our later lectures. So let me first define what is statistics. So according to Croxton and Cowden, statistics may be defined as a science of collection, presentation, analysis and interpretation of numerical data. So basically, a statistic is a combination of various tasks. One is collection, next one is presentation, next one is analysis, and last one is interpretation of numerical data. Now this was initially, in statistics we always dealt with numerical data, but nowadays we also deal with non-numerical data also, right? Non-numerical informations are also called data in modern era, but basically the four major steps or four major methods or four major tasks of statistics is: one is to collect those data, one is to present them in a nice way so that everyone can cope up with them, one is analyze them, and last one is obviously to interpret something meaningful from those data, right? So what is statistics? The word statistics conveys a variety of meaning to people, right? Every people can interpret the word statistics differently. For some may say that statistics is a branch of mathematics which deals with various mathematical tools that can be used to process certain kind of numbers or certain kind of values, right? For some, statistics is just tables, charts and figures, right? So if you see statistics from the point of view of a layman, statistics is nothing but tables, charts, diagrams, figures that you see on newspapers, on televisions, on news channels, or everywhere, or internet, right? You see a lot of figures, you diagram, charts, etc to represent some facts and figures. So that is statistics for a layman. For someone who is very well known with the theory of statistics, he or she may say that statistics is just another branch of mathematics, right? So that is just basic of statistics. Now, how the concept of statistics developed. Statistics was born as a need for administrators. In the ancient human civilizations, kings or rulers used to collect some informations to maintain their citizens or their landmarks in a more effective way. They used to collect information on lands, the populations, the wealth of the citizens, and different things to make policies and collect taxes, right? So they will collect information on what is the land area of my kingdom, how many people are living in this land area, how many of them are working or they are potential warriors or soldiers, how many of them are traders who are earning a good amount of money, how many are agricultural land in my kingdom, from which how many you can say how many amount of wealth is generated every year, so that I can impose certain kind of tax and etc. So all these informations were collected in ancient civilizations or by the administrators to effectively run a certain community or a certain kingdom. But in modern era, statistics is applied in all possible branches of science and humanity, and it is no longer just a science of statecraft, right? So initially statistics was a science of statecraft. That means it is only associated with the land and population and wealth and tax etc of a state. But nowadays statistics is expanded to every corner and every branches of science and humanity. And for example, you can consider biostatistics also, right? Biostatistics is one of the example of these new applications or new branches of statistics, right, where statistics is extensively used. So now the question arises, why we need statistics? What is this importance of statistics that we need to learn it, right? The first thing that statistics helps us is to characterize a phenomena, right? To study the characteristics of a phenomena. By phenomena, I am referring here as anything that we are interested in, any event of interest. So we are interested in something, that event of interest we will call it as phenomena, right? So for example, if I have to simplify it further, if you are interested in the number of COVID patients, right, then that phenomena, that will be a phenomena for our interest, right? The event of COVID positive patients. If you are interested in school going students and various aspects of school going students, or you are interested in the effectiveness of online classes, etc., etc., everything that you are interested in to make a study will be a phenomenon, right? So statistics plays an important role in understanding the different characteristics of this phenomena, how this phenomena is changing, how it behaves under different situations, etc., etc. Everything, it is understood in a better way if you apply statistics to that particular study, right? The next application or the next reason that we need statistics is it helps us to find out the relationship between two or more phenomena, right? So if you are interested in finding out the relationship between one phenomena X and another phenomena or event Y, then statistics can help you. Let's say, for example, X is age and Y is, suppose, the resistance to the current pandemic, right? Resistance to COVID-19, let's say, right? So this age is also a phenomena that or an event or a variable. Later on we will define what is variable is, but in statistics we always refer everything as a variable. So X will be a variable that you are interested in, and resistance to a particular disease is another variable that you are interested in, or this phenomena can also replace by a variable, right? So age and resistance of COVID-19, if you want to see how it relates to one another, how they are related, that then statistics can help you to understand the relationship between them. It will help to measure the amount of relationship, and you will also understand the nature of relationship, whether they are directly proportional, indirectly proportional, etc., etc. All of them are done by statistical tools. That is your second reason why you should learn statistics. The third reason that why you need statistics is it helps you to achieve a certain scientific conclusions, right? With the help of data, with the help of different statistical tools, you will be able to achieve at a certain conclusion based on those available information, right? So if you have 100 informations about a variable X or an event X or a phenomena X, from those 100 information you can attain at a certain conclusion, you can make that conclusion, and further you can generalize that conclusion from a larger group, right? So those 100 informations were randomly selected from a larger group, and based on those 100 information you have attained at a particular conclusion, and with the help of statistics you can generalize or you can apply this conclusion to the larger group, right? We will discuss about this smaller group and larger group in details later on, but that is another usefulness of statistics. Now the last, or not necessarily the last, but the next one is to make valid comparison, right? Statistics helps you to compare certain aspects, right? So one important aspect of statistics is providing techniques to compare between different situations and achieving at a conclusion. So one example may be here that you want to compare whether a particular medicine X and a particular medicine Y, whether they are effective in the same way or one is better than the other. In such a situation, you can apply statistics to come to an valid conclusions, right? That is another reason why we should learn statistics. So just like any other experiment or any other study, statistical studies also should follow certain rules and procedures, right? So statistics is heavily dependent on numbers. In short, we can say that statistics is a science of numbers. So just like any other field, let's say for example in case of crude oils, if you have to achieve or if you have to get petroleum, you must refine it, right? It should pass through various stages of refinement. The crude oil will become petroleum or petrol, right? So that it can be used in different automobile engines. Similarly, every information or every number should go through various stages so that we can achieve at a conclusion, right? So that is the step of those are called fundamental steps of statistical study. So we can say that these three are the most vital steps of any statistical study. Now first one is data collection and presentation, right? So these steps is very necessary. Here we collect. Now we will discuss what is data, but this step is the first step in any statistical study that is completely associated with collecting or gathering information. We gather the information that we think that are relevant or we are interested in, and then the next step is to analyze them, right? Once the data are collected and they are presented in a condensed way so that they can be analyzed, the next step we go to data analysis. Data analysis is subjecting your data to different statistical tools. There are so many tools available to achieve at a conclusion or to get a result, and that part is called data analysis. Once you analyze the data, the next step is drawing a valid conclusion, right? So the first step is you will collect the data, you will go and collect information. Next, you will make tables or you will concise them, you will represent the data in a valid way. Next, you will analyze the data, and the last part is from the result of this analysis you will make valid conclusions. So these three are the major steps in any statistical study, right? One word that we are repeatedly mentioning so far is data, right? So we are repeatedly mentioning the word data. Now let's explain and let's understand what is statistical data. We can say that data is that foundation on which the entire structure of statistical analysis is based, right? So if your statistical data or the quality of your data is not up to the mark, your statistical analysis will also suffer, right? So the quality and the way how you collect data and how you define your data is very important for the successful conclusion or valid conclusion of a statistical analysis, right? So what is statistical data? So not all information that you gather are called statistical data. That you should remember. Not all information is statistical data. So information collected with a predetermined objective in mind, either in terms of numbers or attributes, are called statistical data, right? So you should emphasize on this phrase, that is predetermined objective. So for any information to be statistical data, you must need certain objectives, right? So in any study, there are obviously certain objectives, and if you collect information related to that objectives, only then those informations will be called statistical data, Some examples of statistical data are: if you collect vital states of a patient before admitting to hospital, right? So every online shopping website collects information on consumer satisfaction, right? We give ratings to a product, etc., etc. So these are all informations, right? So these vital states, there is a certain objective or there is a certain predetermined reason why we're collecting this information, right? For a better treatment. Similarly, there is also a certain objective, right? We are collecting this data so that we can treat them in a perfect way, right? So that is statistical data. Now, statistical data are two types. One is numerical data, one is called categorical data. So depending on the information that you collect, they will be divided into these two types, right? So what is numerical data? If your data has any particular scale of measurement, right? So information that can be measured using any scale is called a numerical data. So remember the word scale, or we can measure it. For example, body temperature. If you take the example of body temperature can be measured in terms of degree or Fahrenheit, right? So there is a scale. Degree is a scale, Fahrenheit is a scale based on which we can measure the body temperature of a person, right? Height can be measured in terms of meters, centimeters, or feet, right? We can measure height of any object or human beings. Similarly, we can measure the weight also, and in case of weight we have certain scales. One is gram, one is kilogram, or one is pound, right? So these are called numerical data, right? So those informations that you collect can be measured by means of a scale. Now this scale can be anything, any unit, right? So temperature is expressed in terms of degree or Fahrenheit, that is an unit. Similarly, height is measured in terms of meter, centimeter, that is unit. So that means if your data has a unit, that is called numerical data, right? For some examples, for example of numerical data, suppose 5 patients were admitted to the emergency ward of a hospital. Their vitals were such as random blood pressure, blood sugar, blood pressure, body temperature are recorded for the purpose of treatment. So if you record these values, if body temperature is recorded in Fahrenheit and suppose the values are 99, 97, 101, etc. Similarly, random blood sugar are these values and blood pressure are this, right? So these are the numbers, right, that are collected. These informations were collected from 5 patients, and since all these informations can be expressed in terms of a particular scale, so these will be called numerical data, right? So numerical data can be further divided into two different types. One is called discrete and one is called continuous. How they are measured, how we can measure them, based on that this can be divided, right? So discrete data, which can take a certain number of values, right? For example, number of students, number of doctors in a hospital, they will always be integers or they can be finite numbers, right? So in certain situations they may not be integers, they may be decimal place and values also, but there is a limited number of possibilities for that particular variable to take values. So if there is a variable or there is a phenomena or event that can take different values but they have a finite number of possibilities, then there's also called discrete data. Or this kind of data where you always get certain integers, right? So there will be never 5.1 students in a class or 7.8 doctors in a hospital. There will always be integer values. Those also called discrete data. For simplicity, let's take any discrete number of observations that a variable can take will be called discrete data, or integer variable that value that a variable can take will be called discrete data. Now next one is information which gradually increase or decrease, that means there is no break point. Those are called continuous data. Or if a phenomena or event can take infinite number of possibilities, right? If it has infinite number of possible values, then that also is called continuous data. One example is temperature. There is no breakpoint in temperature. Temperature always increases in a certain flow. Similarly, pressure is also a continuous variable. So this is a graph for continuous variable where you don't have any kind of breaks, right? On the contrary, this is a discrete value, right? So here it is possibility, here it is possibility. So there is a gap, right? This is a gap, this is a gap, this is a gap. So this is a graphical or a chart to represent discrete data. If you plot discrete data, you will get this kind of chart. This is a chart for continuous data. That means there is no gap in the possible values, right? No gap. Now let us discuss about categorical data. So far we have been discussing about numerical data, that means numbers. So there is another kind of data which does not involve direct numbers. Those are called categorical data, or these are also called as attributes. Categorical data are also called as attributes. Okay. So the information which cannot be measured by any scale but only can be counted for presence or absence is called categorical data or attributes, right? So the word categorical data and attributes means the same. Examples are like or dislike for a product. You cannot measure like or dislike for a product. You can only express it, whether you like a product or dislike a product, right? Similarly, positive or negative in a COVID-19 test, you cannot measure it. You can only categorize a person whether he is positive or negative for a test, right? Similarly, gender, educational qualification, marital status, ethnicity, mother tongue, etc., etc. If you collect information on these particular variables or events or phenomena, in this case you will always get a certain category. In case of gender, you will get information on 3 completely disjoint categories, right? Male, female and third gender. Similarly, educational qualification, you will get different categories and a person will say whether he or she falls to that particular category or not, right? So this kind of data, if you have information of this kind, those will be called categorical data, right? Now categorical data are of 2 types. How you measure them, those are called nominal and ordinal, right? So that means categorical data further can be divided into 2 types. One is nominal categorical data and another is ordinal categorical data. Now what is nominal data? When a categorical variable or a quality cannot be arranged in a particular order, or there is no natural order, right? No natural order of preference. For example, in case of gender, you cannot say that a particular gender is less than another gender, right? So in case of similarly religion, we cannot say that one religion is less than another or so on. That means this kind of information does not have an order, right? You cannot arrange them in any particular sequence. There is no natural sequence to arrange them, right? So the name also suggests nominal means no natural order. So this is what you should always remember: nominal, no order, right? Similarly, ordinal data is if you have a particular natural order, right? Can be arranged in a natural order, right? So for example, educational qualification. In case of educational qualification, we can arrange them in a sequence. Illiterate will always come lower than primary. High school will always be will be more preferred than primary. College will be more preferred than high school, etc., etc. That means there is a natural way to arrange this information. Similarly, the risk for a disease, low risk is always preferred, right? Medium risk and high risk. So there is also a natural order to arrange them. So then it will be called ordinal data. That means categorical data which can be arranged in a particular sequence is called ordinal data. Now that we have discussed what is statistical data and what are the different types of statistical data, let's also learn how we can collect those data, right? What is the process of gathering those informations or data for a particular study? Now, this collection of statistical data is very vital for a successful statistical study. If you collect your data in an appropriate manner, then your analysis and finally the conclusion drawn from that particular study will be valid. If you collect those informations with mistakes, if those informations are not collected properly, then it will reflect in your final interpretation or analysis also. Now, before discussing the methods of collecting statistical data, let us get familiar with few terms that we will be frequently using in this particular section, right? That means in collection of data. The first term is population, right? So what is population? The universe of concern. That means according to your interest, the area in which you are interested, every item that falls or that satisfies the criteria to being included in your sample will be called a population. So unlike the dictionary meaning of population, which state that the number of individuals living in a particular area or geographical area, in case of statistics, we use the word population in a broader way. We not only include human beings or living organisms, we also include items in population. So let's, for example, you are interested in making a study on smartphones, then the entire collection of smartphones in the whole world will be the population, right? So those items can also constitute a population. Now, if you select a few from this universe, if you randomly select them, then it is called a sample, right? If you select few items from this population, then it is called sample. For example, in India, we have a number of states and different peoples living in those states, right? So from this entire division of states, if we randomly select few states, these states are selected, and from these states we randomly select few people, right? Then this will be called as the sample and this will be called as the population. Suppose we are interested in the height of Indian male, right? So for that we will have to consider every male living in this country, right? So that will be our population, every man living in this country. Then we randomly select few states, and from those states we randomly select few people. So these few people will be called the sample, right? So that is the definition of population and sample. Now any study that is based on the entire population, now in case I have the time and money and power to study each and every Indian male, and I can measure their height, visit every Indian male and measure their height, then such a study will be called a census. Now if you don't have the time and you rather select a small group from the larger group, that means a sample, and a study is based on those sample, then it is called a survey. So the basic difference between census and survey is census is for population, survey is for sample. right? So these are some terms that we commonly use: population, sample, census, survey, right? So if a person, that means in this our case Vivek, is interested in knowing this question, right? Do you like Arijit Singh or not? So he will go to different people, few of his friends, and he will go and ask this question, right? So that is a process of collecting data. Now the process of the collecting data clearly divides two types of people: one which has a question in mind, one which has an answer in mind, right? In this example, Vivek has a certain question in his mind, right? And Dhruv, Sakshi, Apurva and Kusal, all of them has a answer for that particular question, right? So this leads to the next definition, which is called enumerator. The person who is conducting the study or has a question to be answered is called enumerator. We also call it as investigator. So enumerator and investigator are the same. So the person who is conducting the study or who has a particular question in his mind is called enumerator. The person who provides information is called respondent. So in this example, Vivek is an enumerator or investigator, and all four of them are respondent. These are respondent, right? So these two are the word that is also associated with collection of statistical data. So now, according to the way data are collected, they are of two types. One is called primary data, another one is called secondary data. So if the enumerator or investigator collect the data himself, that means first hand data collected by the enumerator, then it is called primary data. Now if the investigator is not collecting the data, that means he is using already collected data by someone or second hand data, then it is called secondary data, right? So let's explain this. If the enumerator goes to the respondent, then it is called primary data. On the other hand, if the enumerator goes to a third party source, right? This can be internet, and there are various sources of secondary data. And this secondary data, that means this third party source already collected those data from the original respondent, right? Then this is called a secondary data. So enumerator directly going to the respondent will be primary data. Enumerator going to a third party, that third party already collected information from respondent, then it is called secondary data, right? Now primary data can be collected by these different methods. There are 5 different ways to collect primary data. The first one is called direct personal interview. Next one is indirect personal interview. Next one is with the help of local agencies. Then we have mailed questionnaire and we have schedule, right? And this schedule method combined with direct personal interview is the most common form of collecting primary data in modern age, right? This is the way we collect most of the primary data in nowadays. Okay, let's go and discuss what is direct personal interview. In this case, the enumerator directly goes to the respondent and collect information verbally, right? The interview is verbal. The enumerator will go and collect information from the respondent, gather knowledge verbally. He will ask different questions to gather information, right? So this is completely oral interview, right? In this case, the informations are collected orally and then the analysis is done. So this is good for small scale study. So if you have to visit the people yourself, then obviously every visit will require some amount of money and some amount of time. So if your study is small, let's say you have to visit only 30 people, then it is preferable. You can go and question those respondents yourself, but or even less than 30. But here it is very time consuming and costly. This method is very time consuming and costly, but it gives you high degree of accuracy. So what are the good things about here? That it is very accurate, but the bad thing about here is that it is very costly and time consuming, right? That is direct personal interview. Now there are certain situations where directly going to the respondent and questioning them about a particular information may not give you the desired answer. Let's say, for example, you are making a study on drugs habit and this is your respondent. If you directly go to the respondent and ask about this drugs habit, the respondent may not answer properly or may give you wrong answers, right? So in such a case, the enumerator take help from a third party, right? And this third party should be very close to the respondent and should have adequate knowledge about the respondent. One may be the friend or family members or doctor or neighbors, etc., etc. So this enumerator will go to this third party. This third party will provide those informations about the respondent. The enumerator here is directly going to this third party, right? So that's why it is a primary data. So this is economic and time saving, but the information may not be reliable. So if the third party does not have an adequate knowledge about our respondent, he or she may provide us with some very vague or inaccurate informations. So that's why the information may not be reliable in most of the cases, but in case of these critical questions, that is the only way we can collect information, right? So that is indirect personal interview. The next one is through local agencies. Now, if your study area is very large or very scattered geographically, then for the enumerator to conduct the entire study himself or herself may not be possible. So in such a case, let's say your study is based on the entire Northeast, right? You are conducting a study on entire Northeast of India, right? In such a case, the enumerator cannot visit each and every state or each and every district under study. So he or she will hire some people. These peoples will be hired who are local to that area. One may be from Assam and he will collect information on Assam. One may be from Meghalaya who will collect information from Meghalaya. One may be from Arunachal and she will collect information from Arunachal, right? So these are called local agencies or local correspondents, and these local correspondents collect information from their locality and they revert back to the enumerator. They will send back the information to the enumerator, right? The good thing here is that it is less costly, easy and perfect for large, right? But if the local agencies does not carry out the study effectively, then it is less efficient. Okay? So that is collection of primary data through local agencies. Now the next one is mailed questionnaire. So what is a questionnaire? Questionnaire is a list of questions with space to write down the answer. Right? Imagine your admission form. Right? In your admission form, there are certain questions, or whenever you apply for a particular job, there are certain questions and then we have space to write down the answer. Let's say, for example, name, address, etc., etc., right? So there will be a question and space to write down the answer. That is called a questionnaire. Now if you mail this questionnaire or set of questions to a particular respondent, so the enumerator will prepare a list of questions. He or she will mail them either electronically or by conventional postal methods to the respondent. The respondent will read the list of questions and write down the answer, right? So there will be a question, the respondent will fill the answer, then the respondent will again mail that answer sheet to the respondent, either electronically via email or by conventional postal method. So this is called mail questionnaire. Now what are the good things about here is that a large area can be covered. It is very less costly and quick. Why quick? Because nowadays with modern technologies, with emails or with internet, you can send lakhs and thousands of these questionnaires to respondents, right, instantaneously, and they can fill them and revert back to you within a very small amount of time. But there is a drawback, that is, this is only applicable for literate population. That means in this study you can only include those literate respondents who will be able to read and write down their answers and then revert back to the enumerator. You cannot include illiterate people in this kind of study. That is one drawback. So to remove the drawback, we introduced schedule, right? So what is a schedule? A schedule is similar in appearance to a questionnaire, a list of questions with space to write their answers. But in this case, they are filled by the enumerator. That means the enumerator will go to the respondent. He or she will ask the question. The respondent will provide the answer. The enumerator will write down the answer in this list of questions. That's the process. That means a direct face-to-face situation where the enumerator goes to the respondent, asks the question, the respondent gives the answer, the enumerator will write down the answer in his list of questions. That is called schedule method. Now here the advantage is it has better accuracy and it is very flexible, because depending on the situation you can add or remove certain questions also. Further, it is also applicable to illiterate population, because even if the respondent is not familiar with reading and writing, if the enumerator can dictate the question and the respondent will answer it verbally, the enumerator will write down the answer, right? But the drawback is it is time consuming and costly. Why? Because the enumerator will have to personally visit each and every respondent, right? So that is how we collect statistical data of primary kind, right? So here is an example of a schedule or questionnaire, right? Here we have a question called name, a question called age, sex, we have options, we have educational qualification, etc., etc. Now if you mail this questionnaire to a respondent, then it will be, or list of question to a respondent, then it is called questionnaire. Then it is called questionnaire. Now if you go personally and ask the question, they will give you the answer, then it is called schedule, right? The appearance of questionnaire and schedule are same, they look the same. Only difference is questionnaire is filled in by the respondent, schedule is filled in by the enumerator, right? So now that we have discussed how we can collect primary data, we can also discuss what are the different sources of secondary data? Now, secondary data are very easy to collect, right? You can collect them from internet, you can collect them from journals, from books, from research reports, from government or official or unofficial publications, right? These are all secondary source of secondary data: internet, journals, book, research reports or publications, right? And there is no hard and fast rule how you can collect secondary data. You can collect this data as it please your objectives, right? So here is a comparison between primary and secondary data. The good thing about primary data is it is efficient, flexible, and good for detailed study. And the good thing about secondary data is it is less costly and fast, easy to collect, and good for overview study, right? The bad thing about primary data is very costly and time consuming. The bad thing about secondary data is it is very less accurate, right? And not flexible. Why not flexible? Because someone already collected those data according to their way. You cannot change it. You can only use those data, right? So that is a comparison between primary or secondary data and how we can collect primary data and secondary data. Now that we know how to collect statistical data, either primary or secondary, the next thing is to make them concise, right? For that we use statistical tables. Now, tables are a way to look your data in concise and so that you can instantaneously make some conclusions about the data, or you can have an initial idea about your data. So how to prepare a statistical table? To prepare a statistical table, we classify our data according to various characteristics, right? So classification of data means taking different items having common characteristics. So in your data, the different values or numbers or classes may have a certain common characteristics. We identify that common characteristics and group different values according to that common characteristics, right? So once our data is available to us, we will classify them into different groups. Now classification can be either with respect to a single characteristics, or you can classify the same data set according to multiple characteristics, right? So this classification is the first step of tabulation. That means to make a table or statistical table, you have to classify your data into different groups, either in according to a single characteristic or according to multiple characteristics. So let's take an example that we have 7 people. We asked them about their age, right? They responded us with their ages in terms of years. So we have different values. So if you don't make a table, the data will look like this, right? This is an ungrouped or uncategorized data. You have not made them concised. Now this data can be either classified according to gender. So these 7 people can be classified according to gender, male and female, or you can classify according to their age, right? You can classify similar age people into a group, similar age people into a group, and similar age people into a different group. So this data can be classified either gender wise or either their age wise. So this is called classification. Classification means you will group items that has a common characters. In this case, the common character is 19 years old, right? Common character is 20 years old. So the table 1 in the above is a classification of 40 patients according to one characteristics, which is their gender. So we have 40 patients in the last week, and I have classified them according to their gender, male and female. We have 25 male and 15 female patients in the last week, right? So this is a one-way classification. This kind of tables are also called one-way classification, right? On the other hand, the same data, apart from their gender, if I classify the number of patients according to the days in which they have been admitted to the hospital, that means every Monday to Sunday, then I get a different kind of table, right? So the same 40 patients, now they have been classified according to two different categories or characteristics. One is day on which they were admitted, and another one is gender, right? So this kind of table, these are called two-way classification, right? So these are called two-way classification. This is one way, that means we are categorizing or we are grouping the data according to one character. We are grouping here the data according to two characters simultaneously. Now, to make a table, you need to understand the term called frequency. This word frequency or this term frequency is very commonly used in statistical analysis. So what is frequency? Frequency is nothing but number of repetitions. So how many times? So if we go back to this example, out of these 40 patients, the frequency of male, that means how many times males occurred, is 25, right? And how many times female occurred is 15. So 25, this 25 will be called frequency of male patients, right? It will be called frequency of male patients, and this 15 will be called frequency of female patients. So number of repetition, how many times it occurred or how many times it is repeated, is called frequencies. Similarly, this 5 will represent the frequency of male patients in Monday, right? 2 represents frequency of female patient in Monday, and so on. So in short, frequency is number of repetition. So for example, if I say yes, yes, no, yes and no, in this case yes is repeated 3 times, right? That's why yes has a frequency of 3. And no is repeated 2 times, that's why no has a frequency of 2. Okay, so frequency is number of repetition. Now based on frequency, how you group those frequencies, we have two different kind of table. One is called ungrouped frequency table and one is called grouped frequency table. This ungrouped frequency table is also called discrete frequency table. Now don't confuse this with ungrouped data. Ungrouped data is a completely different thing. Ungrouped data is those data where you don't group them. Say for example, in this case we have just some values, right? Information, yes, yes, no, yes, no. We have not classified them according to any criteria. So if you don't classify your data, that data is called ungrouped data. Okay, if you don't make any tables or group or classification, those kind of data is called ungrouped data. If you make certain kind of group or grouping, either discrete or continuous, those are called frequency data or grouped data, right? So depending on how you make the frequency or how you group the frequencies, we have two different types of frequency table. One is discrete and one is continuous. So let's say for example, an enumerator, this person has a question. The question is, do you watch YouTube or not? And he goes to 20 different peoples and asks them, do you watch YouTube? And they will reply with either yes or no, right? The answer will be either yes and no. So if you leave your data like this at the end of your survey, that you question 20 people whether you watch YouTube or not, they will answer either yes or no, and you just reported the data like this. This will be called ungrouped data, or sometimes it is also referred as raw data. This is the raw data. That means we have not classified them, we have not make any tables and so on. Now if the enumerator prefers to classify them according to their preference, whether they yes, how many people reported they watch YouTube, how many reported they don't watch YouTube, right? So we are classifying these 20 people according to their preference, yes and no. And this 30 will be the frequency of yes, this 7 will be the frequency of no. So this kind of table is called ungrouped frequency table or discrete frequency table, right? Ungrouped frequency table or discrete frequency table. Now what is group frequency table? If the same enumerator, apart from the choice of YouTube or not, asks their age also to the same 20 people and they reported their age, right? So we have different values, right? Different values of their age. Now if the enumerator decided to note down each and every individual age and how many people are from these different ages, then in this case we are considering every individual age. Every individual age is being tabulated. So this kind of table is called discrete or ungrouped frequency table, right? So if you don't cluster them, that means if you don't combine them, then it is called discrete. But the same thing can also be represented as like this. If you divide the range into certain classes, that means 19 to 20 is a different range, 23 to 26 is a different range. That means rather than writing all the ages individually, we have further grouped them. That means 19 to 22 is a group, 23 to 26 is a group, and then we count how many people falls in this particular range. That means how many people, right? 3 to 5, 5 plus 1 is 6, 6 plus 4 is 10. So that means 10 people has age between 19 to 22, right? Similarly 10 people has age between 23 to 26. So a table like this is called continuous frequency table or grouped frequency table. Continuous frequency table. This word is more appropriate than only using group frequency table. So whenever you see a range like this, you call it as continuous frequency table. Whenever you see some individual values, then you call it as discrete frequency, right? So there are certain terms that we should know in case of a continuous frequency table, right? So if you have ranges like this 0 to 10,000, 10,000 to 25, etc., etc., then this value, the values towards your left hand side of this column, there are two columns, right? One has the range of monthly income, one has the number of persons. So this number of person or how many people falls in this group, these are called frequencies. These are frequencies. And the value towards our left of this range are called lower class limit. These are called lower class limit. And the values towards our right, the green one, are called upper class limit, right? And the difference between these two the difference between 0 and 10,000 will be 10,000, right? 10,000 minus 0, 10,000. This value, the difference between these two, or the difference between these two, in this case 10,000 and 25,000, the difference will be 15,000, right? Here it is 10,000. So these differences are called class width. So we will need these terms, lower class limit, upper class limit, and class width, in certain formulas. One example is in case of median. When you calculate median for this kind of data, we need the knowledge of lower class limit, class width, and upper class limit, right? So this is different terms that we use. So these are frequencies. The number of repetition is frequency. The values towards your left are called lower class limit. The values towards your right are called upper class limit, and their difference is called class width. Okay. So next is how to calculate cumulative frequency. There is a term called cumulative frequency which we use in case of certain formulas, and let's see how we can calculate cumulative frequencies. For the same example, that means 10 to 10,000, that means we have monthly income, certain range of monthly incomes, and certain number of persons who falls in this range. That means there are 25 people whose monthly income is between 0 and 10,000. There are 15 people whose monthly income is between 10,000 and 25. There is 100 people whose monthly income is between 25 and 50, 30 between this range, and 5 with income more than 1 lakhs per month, right? Now there are two types of cumulative frequency. One is called less than cumulative frequency, one is called more than cumulative frequency. So this less than cumulative frequency calculates how many values falls less than our upper limit, right? So the less than is always associated with the upper limit. This you should remember, less than is linked with upper limit, more than is linked with your lower limit. That's why these are green, associated with the green, these are yellow, associated with this yellows. So what does less than cumulative frequency means? Less than cumulative frequency gives you the number of items that has value less than the upper limits. So that means this 25 represents how many person has income less than 10,000. So 25 has income less than 10,000. Now if I add this 15s also, right? So I need how many people has income less than 25, right? So obviously this 15 people has income less than 25. On top of that, this 25 persons who earn between 0 to 10,000 also earn less than 25, right? So we have to combine them. That's why we have added 25 and 15. Now we need how many people earn less than 50,000. Of course, this 100 people earns less than 50,000, but on top of that, this 15 and 25 also earn less than 50. That's why we have added all three of them. Similarly, for less than 1 lakh, we have added this 30, 100, 15 and 25, right? So this is how we calculate less than cumulative frequency. You don't have to write this every time. You don't have to expand this. Just simply remember this trick. The first value will be same, right? This will be same, right? Then you go diagonally to down, you plus, you equal. That means 25, you go this direction, add the value, and the answer will be in this direction. Similarly, the value here is 40, right? 40 diagonally down, plus, equal, 40 plus 100 is 140. So this is the way how you calculate cumulative frequency less than cumulative frequency, right? Now greater than cumulative frequency, the easiest way to calculate them is going from bottom to top. You write the first value same, that means 5 is 5, then you go diagonally up, add the value, write it here, that means 5, 35, 35, 35, 100, 135, 135, 15, 150, 150, 25, 175. Okay, so this is how we calculate cumulative frequency. Okay, now one thing that you should check here whenever you are calculating cumulative frequency, and I have seen many students making the same mistake, that if you add this value 25, 15, 100, 30 and 5, you should get 175 if you add this value. So this value is called total frequency. This value is called total frequency, and it is normally denoted by capital N. We denote total frequency by capital N. Okay, so you should always check that whether your total frequency is equal to the last value of your less than cumulative frequency and the first value of your more than cumulative frequency, right? So what does less than cumulative frequency gives? How many number has frequency less than this value. What is more than frequency? The number of people who reported greater than this lower. That means how many people in this example, how many people has income greater than 0? All of them. How many have greater than 10,000? Except this 25, right? So 150. That's how we calculate cumulative frequency. Now we all know that tables are not that interesting to look at, and also it is not very convenient to draw conclusions just looking at a table, right? In such a case, we take the help of pictures, right? So pictures plays a very vital role in statistics, and we use the help of pictures in drawing conclusions. So why we should visualize data, right? There should be a reason why you use this visualization. Let's take an example that in a T20 match, this is the performance of two teams, team A and team B. Now just looking at this data, this is a completely raw data without being classification or tabulation, and just looking at this data we cannot make any conclusions, right? We obviously know which team won at the end, right? But we don't know how they performed, whether one is completely different from the other or not. But as soon as I plot this data into a graph or diagram, then we can see that their performance, right? We can see the consistency of their performance, and the game changes in the last 3 hours. The game change in this portion, right? So that is the power of a visualization of data. With the help of visualizing data, we can make them easily understandable. Also, we can conclude from a visual representation of data, right? Drawing a conclusion is very easy, right? So there are two types of visualization based on how the data is grouped or classified. We have two different types of visual representation. One is called diagrams, one is called graphs. Diagrams are for ungrouped data, or ungrouped is also called discrete frequency data, right? This is for discrete frequency data, and graphs are for continuous frequency data, right? So we use graphs for continuous frequency, we use diagrams for discrete frequency data, right? So let's start with diagrams. So these three are the most commonly used diagrams. First one is bar diagram, next one is pie diagram, and then last one is line diagram. Now bar diagram has certain categories. One is simple, one is multiple, and one is stacked. Now what is a bar diagram? As the name suggests, it consists of bars, right? So this is a bar diagram. Here we have an XY plane. So these are all two-dimensional plane, right? Diagrams, sorry, two-dimensional diagrams. So in a two-dimensional diagram, except from this pie chart, line and bar are two-dimensional. That means that is plotted in a 2D graph. So in a 2D graph, we have two axes, x-axis and y-axis, right? Conventionally, bar diagrams are plotted along this x-axis, but you can also plot them along y-axis. It does not matter. So here we have certain bars, right? This height of this bar represent the frequency of the item that it is representing. So let's say this is, suppose x, this is y, this is z, and these values are, right? So 1, 2, 3, 4, 5. That means x has a frequency of 3, y has a frequency of 2, and z has a frequency of something greater than 5, or let's say 6, right? So this is how we plot a bar diagram. We have certain bars separated by a gap, and the height of this bar represent the frequency, or they are in proportion to the frequency, right? So these are called bar diagram, and the gap between every bar should be equal, and the width, that means how wide these bars are, should also be homogeneous, right? That is one property of bar diagram. So there are three different types of bar diagram. One is simple, multiple, and stacked. So let's see what is a simple bar diagram. In a simple bar diagram is based on a single classification. That means if your data has only one classification, that means it is classified according to only one category, then we use simple bar diagram. This is just for a visual representation, right? So suppose in the month March we have 25 patients in a particular ward. In the month April we have 40 patients in a particular ward, and in the month May we have 25 patients in a particular ward, right? So if I have to represent this data using a simple bar diagram, I will plot the different months in the x-axis and the number of patients, that means the frequency, along y-axis, right? So this is the bar diagram to represent this data. Now here the classification is only based on the month, right? Now imagine the same data, but in this case, apart from the month in which they were admitted, we also have classified them according to their gender. That means we know how many male and how many female. In such a case, if I have to visualize them, I will use multiple bar diagram. That means for the same month, we have two different categories now. For the same month, we have male, we have female. For the same month, we have male and female. Now what is the advantage of this? This gives us a way to compare the ratio, right? In which month we have more male, in which month we have more female. Instantaneously we can say that in the month of March we have more female compared to male, but in case of April and May we have more male compared to female. So bar diagrams are very good for comparison. Now the same data you can also represent by this. So total 10 plus 15 is 25 patients in March month. So we draw a bigger bar diagram representing this entire 25 patients. Now from this diagram we divide it into proportions. That means there are 10 male, so we divide the box into 10 male and 15 female. So this is called stacked bar diagram, right? So this is stacked bar diagram, this is multiple bar diagram, and this is simple bar diagram. The one common characteristics of bar diagram is it is very good for comparison. See, we can compare that which month has the highest number of patients. Instantaneously we can say that April has the highest month of patients with the help of a simple bar diagram. Here also we can instantaneously say that which month has the highest number of female. So that will be both March and April has highest number of female, right? Which month has the highest number of male? April has highest number of male. Here also we can say which has the highest number of patients. This month April has the highest amount of patients, and it also has the highest amount of male compared to other months, right? So these are the three different bar diagrams. Now what is a pie diagram? A pie diagram is a division of a circle. We divide the area of a circle according to the proportion of the frequency, right? So in the month of March we have 25 patients, here we have 40 patients, and here again we have 25 patients. So we have divided the entire, this is not sales, this is number of cases. So we have divided the entire region or the entire area of the circle according to these values: 25, 25, 40, right? This is 25, this is 25. Now the way we divide it, we first convert these values into degrees. We know the total angle of a circle is 360 degree, right? So this 360 degree is actually divided according to this proportion. How we can divide it? Let me give an example. This example. So we have March, we have April, we have May. Now the frequency F is 25, 40 and 25. Now we need the degree, right? So degree, to find out degree, first we will calculate the total frequency. That means here if I add 25, 40 and 25, it will be 90, right? So this is the total value that have to be divided. So now we calculate the degrees using the formula. The value of frequency divided by total frequency, that is 90 into 360 degree. Similarly for here it will be 40 divided by 90 into 360 degree, and for this 25 by 90 into 360 degree. So basically the formula is frequency divided by total frequency into 360 degree. This will give you the angle that this portion is supposed to cover, right? So that is how we draw pie diagram. Now pie diagram is based for representing share of subgroups, right? So in total there are 90 patients in these 3 months, right? So if you want to distribute these 90 patients, or if you want to see how these 90 patients are distributed throughout these 3 months, then pie diagram is the best option, right? So you have a total amount which are divided according to one criteria, and you want to see how many percentage falls in different categories, then you use pie diagram, right? Pie diagram are best for representing shares. And the next diagram we often use is called line diagram. Now in case of line diagram, we just plot the value, a dot for the frequency, and then we join them using a straight line. So let's take the example that these are the number of active cases in a week of COVID-19, right? On Monday we have this active cases, on Tuesday we have this active cases, on Wednesday this, and so on, right? So here along x-axis we will plot the different dates, that means from Monday to Sunday, and along y-axis we will plot the different frequencies, right? So on Monday we have approximately 29,500, so it is plotted close to 30,000. On Tuesday we have more than 30,000, so this is the value. So initially we will plot these dots, right? First we will plot the dots, then we will add or join these dots using a straight line, right? So that is called a line diagram. Now in which case we use line diagrams? Line diagrams are best for chronological data. Now chronological data means time series data or data which has a natural sequence of time. In this case, see, we are going forward in a sequence, Monday to Tuesday, Wednesday, Thursday. That means we are going day by day. So when your data is related to time or it is changing over time, then line diagrams are best to represent those kind of data. Now to represent continuous frequency data, this is used for continuous frequency table or data, right? Continuous frequency data. Now the three different graphs that we use to represent continuous frequency data are histogram, frequency polygon and curve, and ogive. Now frequency polygon and curve are same thing, and histogram is quite similar to bar diagram, right? So this is how we plot a histogram. So suppose you have certain data which says we have a class group of 1 to 5, 5 to 9, 9 to 13, 13 to 17, 17 to 21, 21 to 25, right? Let's say these are ages. These are different ages 1 to 5, from 1 year to 5 year, 5 year to 9 year, 9 year to 13 years, 21 to 25 years, right? And these are numbers, right, or frequencies. That means we have 5 people in this 1 to 5 group, right? We have 11 people in 5 to 9. We have 24 people in 9 to 13, or this is 23, this is 24, and this one is 9, and then we have 4, right? So in the age group 1 to 5 we have 5, let's say, patients. In the age 5 to 9 we have 11 patients. 9 to 13 we have 23 patients. 13 to 17 we have 24 patients. 17 to 21 we have 9 patients, and in the last 21 to 25 we have 4 patients. Now if this is a continuous frequency, right, so we have undivided range, right? These are all continuous. So then to represent this data we use histogram. Now this is similar in appearance to bar diagram. The only difference is in case of bar diagram the different bars has a gap between them, but in case of histogram we don't have any gap. All the bars are side by side without any gap. So this is how we draw histogram. Now what is the use of histogram? With the help of histogram we can see that within this range, that means from 9 to 17 we had the highest number of patients, right? So this is the most occurred range, 9 to 17. Similarly 1 to 5 and 21 to 25 has the least number of patients, right? So we know how the values are changing. It is increasing at the middle and it is decreasing towards the end. This is the purpose of histogram. Now on the same histogram This was our original histogram. Let me clear this. So this is our original histogram. Now if we point out the midpoints, that is the middle value, 1 to 5 the middle value, 5 to 9 the middle value, 9 to 13 the middle value will be here, the middle value here, middle value here, middle value here. Now these are the middle values. If you join these middle values using a straight line, if you join them using a straight line, then it is called frequency polygon. Now frequency polygon are not drawn alone, they are always drawn on top of a histogram. So you don't draw frequency polygon without a histogram, you will draw them on top of a histogram. And then if these same points, these circles are instead of a straight line joined using a freehand smooth curve, then it is called frequency curve. That means if we join these dots using a freehand smooth curve, we get frequency curve. The same histogram, if you join the midpoints using a straight line, it calls as polygon. If you join the midpoints using a freehand curve, it is called frequency curve. Right? Now ogive is based on, or it is a visual representation of cumulative frequencies. Now we have already learned that we have two different kinds of cumulative frequencies. One is called less than cumulative frequency and one is called greater than cumulative frequency. Similarly, we have two different kinds of ogive also. One is less than ogive and one is greater than ogive. Okay, so less than ogive will always be increasing and greater than ogive will always be decreasing in nature, right? So along x-axis we have the different values and along x-axis we plot the cumulative frequencies. These cumulative frequencies are plotted. Now we know that cumulative frequencies, less than cumulative frequencies are always increasing and greater than cumulative frequencies are always decreasing. That's why the graph is always towards the downward, the graph is always upward. So these are called ogive. Now if you plot both of them in the same graph, less than cumulative frequency or greater than cumulative frequency, there is a point where they intersect. If you plot less than and greater than, there will be a point where they will intersect. Now this point is very important because based on this we can calculate something called median, right? So median can be visually calculated using ogive. That is one of the application of ogive, to find out median, right? So these are different kinds of visual representation tools that we use in statistics. So this is a brief comparison. So bar diagrams for comparison, right? Pie diagram to understand proportion. Line diagram is to show something that changes over time. If you want to show whether the price of petrol is changing over time, you will use line diagram, right? If you want to show in which section you spend monthly, that means in the different section how you spend your money, then you will see or you will draw pie diagram. If you want to compare the number of students or number of patients into different categories, then you will use bar diagram. And histograms are for finding frequencies in case of continuous frequency data. So this is all about the preliminary knowledge that we need to understand statistics in a better way. So far we have discussed what is statistics, how it was developed, what are the different terms that is associated with statistics. We have learned what is statistical data, what are the different types of statistical data. Now how we can collect this statistical data, primary data and secondary data. Now after collection of data, how we can classify them and make tables from this data. and also how we can represent this data using different diagrams and graphs, right? So this is all about this lecture. From the next lecture we will start on actual mathematical formulas or statistical tools that are being used for analysis. That's all for this one. See you in the next one.